Hello everyone, my name is Antonio Coleman and I would like to welcome you to my final video of this series. However, before we begin, I would truly like to say thank you to everyone who started this journey with me from my first episode where I covered some general background information about BST red-black trees. Through this series, we have covered things like what red-black trees are, their self-balancing properties, the actual origin and documentation that led to their inception, real-world use cases, and many more concepts. However, in our final video together, I will be covering a C++ market ledger that utilizes BST red-black trees as a key component. For those of you who may not know, a market ledger is essentially a record book or collection of accounts where all business transactions can be stored and also summarized. This may be useful to keep track of things like balance sheets and loss profit statements. Now let's discuss the program. Here is a snippet from my .h or header file. In my header file, one important thing to note is that the core data structure that makes this application possible is augmented red-black trees. Additionally, some color helps me establish the red and black properties that are required for the self-balancing logic of the tree. Furthermore, for struct node, this helps act as a critical building block for the program. Now it's time to move on to another snippet from my header file. Some important elements of my private class include the update augmented data node. Here, it acts as essentially the accountant for the program. Now that we've established this, it is time to focus on its actual function. Here, every time a node is rotated or touched, the function recalculates the size, subtree, and sum, and it also recalculates the min and max IDs for the node based on its children. Furthermore, the fixed insert acts as a police officer for the application. Here, after any new transaction is added, which for reference will always be red, allows for a check that looks for any rule violations that may happen within the function. Examples of these violations can be things like two red nodes touching, which will result in call rotations happening to fix them. Now it's time to move on to the public class. Here we see important functions like insert transaction, which adds a new financial record. Here it places nodes like a normal BST, then immediately calls for fixed insert to rebalance them. Additionally, the market ledger constructor is also important as well. This is because it helps to set up the nil node, which is a centennial node that acts as a stopper at the bottom of the tree. For reference, this is colored black and initializes an empty root. Now we can move on to my CPP file. Here, the first portion of the program I would like to talk about is the lazy propagation logic. Here, the push function helps act as a mathematical trick that allows for us to update large amounts of records instantly. Additionally, instead of having to loop through every single child node to add values, which would be very slow, the formula for this would be ON. We get to simply tell the node that everything below it gets an additional plus 10. Through this, now the code is able to instantly calculate the new total sum by multiplying the adjustment by the number of nodes. Now that we've covered that, I would like to briefly talk about the safety net or centennial node. The reason why this is important is because red-black trees notoriously are difficult to code. This is because of null pointer exceptions. This happens when checking colors of non-existent children. By creating a physical dummy node or nil that represents nothing. However, in this program, we can safely ask for nil color or nil left without the program crashing, which would be a common pitfall. A good summary of this is that we're not just storing data, we're caching calculations. Things like subtree sum, size as well. both being in the tree structure itself give us an advantage. This is a key difference between a basic data structure and the advanced system that we covered in this video. However, this will conclude the video and also the series. I would once again like to thank everybody who has watched any of my videos. Thank you for accompanying me along this journey and also tuning in as we learn together. Thank you, and catch you in the next series.